Hi guys, so we did not do all of chapters 9 for that test. We did all the way up to 9.6, didn't do 9.3, but the last part of chapter 9 is 9.7. 9.7 is the last part of chapter 9, and it is working more with trig functions. And really, this first part, we're going to be looking at some of the trig functions and actually finding areas of triangles. Right, so for these here, we can plug these into the calculator. So if we type tangent of 150 into the calculator, we would get an answer. Okay? And if we did sine of 120, then we could do cosine of 95, which would give us 0.0871. Okay? And we could do this with all these here, because we could do tangent, cosine. So we can find these with angles greater than 90, because for the most part, we've only worked with sine, cosine, and tangent between 0 and 90. But we do need to be careful, especially kind of going back and forth, because normally, once we get this square root 3 over 3, we could use the inverse of tangent to try to get back to the angle. And we worked with that, where we got the number and could go back and forth between the angles and the value of sine, cosine, tangent. But we do need to be careful once we start getting bigger angles, because sine of 60 is what? Which is the exact same value as sine of 120. So if I had taken the inverse of square root 3 over 2, it actually would have given me 60, not 120. So there are other properties that that are involved in this, especially going from the angles and comparing it to the side lengths. And if we look at tangent of negative 30, well, we already got that one once, didn't we? For 150, so negative 30 degrees and 150 degrees actually give us the same value. So we do have to be careful, especially going back and forth. Now we delve more into that, and especially the more specifications of how this works and why it works in the trigonometry, and we do cover it in the pre-calculus class of why this works and how it works that way. But that's mainly what we'll look at for that there. And really, I just wanted to show you that we can still find sine, cosine, tangent if the angle is bigger than 90 or less than 0. Now, the first thing we're going to look at is area of a triangle. Well, what is the area formula for a triangle? Divided by 1/2. Divided by 2 or times 1/2 is the area of a triangle. Is 1/2 the base times the height. But we need to know what the height is and the base. And for a right triangle, the base and height are the two legs. For a right triangle, the base and height are the two legs. So we can multiply those together and then times 1/2 or divide it by 2 to get the area. But if we're not given that, say we're only given two sides in the included angle, we can still find the area. Because the area of a triangle, we can define in one of these three ways here. 1/2 BC sine of A, or 1/2 AC sine of B, or 1/2 BC sine of A. Now there is one key thing that does come up, and it's really not talked about too much. Angles are always capital letters, and I believe we've covered that in here. Angles are always denoted as a capital letter. Side lengths are always going to be denoted as a lowercase letter. Now it's not here, we're not just using ABC. You don't have to redraw that triangle because I'm just redrawing it for this here. But side length A and angle A are what to each other? Opposite. Angle C and side length C are opposite. Angle B and side length B are opposite. And they do that on purpose. Because even if it was FGH, this would be F, this would be little f. They always relate them in that way. But for the area for any of these here, really, we're taking 1/2 AB sine of C. Here is equal to 1/2 AC sine of B, or A is equal to 1/2 AC sine of A. In any of these setups, the angle is always between the two sides. If we have two sides and an included angle, we could find the area. So, looking at this here, we want to find the area of this triangle. I do have two sides and the angle in the middle, yes? So the area is equal to 1/2 19 times 17 times sine of 135. Because this here would be our BC sine of A. To the nearest tenth would be 0.2, but I would take that. And that's it. Questions on those here? Now this one here didn't give us A, B, or C. It gave us R, S, and Q. But the area formula still is 1/2 the two side lengths times sine of the angle between them. So it'd be 12, 1/2 times 12 times 15 times sine of 1/2 of the two side times the two side lengths times sine of the angle in the middle. And that's it. Questions on this here? We'll do this one here and then we'll move on. So ABC, well, the two sides opposite angle B should be A and C. Because again, the side opposite angle B would be side length B. So the other twos have to be A and C. Now another way we could do this is draw a figure. A, B, C. Side opposite A, angle A is 19. Side opposite angle C is 14 and B is 60. Oh, we do have two sides with the angle in the middle. So the area for this is equal to 1/2 of 19 times 14 times sine of 60. Yeah, because we'll be dealing with square root of 3 over 2. Say it one more time. Yeah. What is sine of 60? Because I feel like it's 1/2. Square root, huh? Square root of 3 over 2. Okay, yeah. Kind of flipped. All right. Now the other formula that we can look at is Heron's. Heron's formula. Heron's formula is used if we're actually given three side lengths. We're given three side lengths of a triangle and it's not a right triangle. Because if it was a right triangle, well, then we could use the two legs, the two sides that make the right angle, and the 1/2 base times the height. Heron's formula has two parts. The first thing we need to do is find S. And S is the three side lengths together divided by 2. S is just the three side lengths added together divided by 2. So we need that first to find the area. Now to find the area, we're going to take the square root of, well, the value of S times A times S minus C. And that's it. So let's look at the first one of this here. So the first thing we need to do, because we are given three side lengths, is we need to find the value of S. S is going to be our 7.5 plus 14 plus 8 divided by 2. 7, 22, 29.5 divided by 2 should be 14.75. I mean, no, okay. So that's what we needed to find first. Now the area is equal to the square root of S times S minus A times S minus B times S minus C. Now, the values that we choose for A, B, and C really don't matter as long as they are the three sides and we don't repeat any unless it's repeated. And at this point here, we type it in. Yeah. And the values for A, B, and C will never be greater than S. The values of A, B, and C will never be greater than S. Because we're adding three different lengths together, yes? And dividing it by 2. Well, the only way that any of them would be the same is if we were actually dividing it by 3, because there's 3 different ones. Because we had side lengths of 7.5, 8, and the last side length that we didn't use, 14. Yep. I just ran out of room. And this is kind of actually helpful because if you're trying to find the area inside of any triangle, as long as you know the 3 side lengths, you can find it. Because otherwise we would have to find the line, the altitude, the line that goes from one angle to the other side and makes a right angle, and finding its height. Which for these problems here can be somewhat tricky, especially if we don't know the angles, but if we're looking at more of a real life situation, trying to find the exact line that goes straight down and get that exact height isn't always easily done. But here, as long as I know the side lengths, we can actually find it. Questions on this one here? Let's look at this one. So the first thing we need to find is S, which would be 14 plus divided by 2. Yep. This time we needed 14 twice because we had two sides that were 14. Mm-hmm. Yeah. Mm-hmm. Yeah. Fraction form works just as fine. Fraction or decimal, because sometimes writing the decimal might be easier, sometimes writing the fraction would be. So however you want to do it. And we get what? 0.59. Or 60, yeah. Either one works. Questions on this here? Do we need to see another example of this? And that's it. Yes. Kind of, yes. Because we didn't have a vocab sheet because we didn't technically start a new chapter because we're still dealing with the same properties as part of chapter. Yep. And you actually looked up the vocab for this section already. Yes.